Improbable probabilities. Toss a coin 10 times. How many 4 in a row do you expect? I mean, 4 heads in a row. I'm not saying it has to be heads or it has to be tails. I'm just saying you toss the coin 10 times, and what's the likelihood, what's the probability of getting a sequence of 4 somewhere in among those 10, either 4 heads or 4 tails? Now, this is where probability becomes counterintuitive, in other words, not what we expect, because most people would expect 4 in a row to be quite rare, actually. But in fact, it's true randomness means it's actually a lot more common than we expect. In 10 tosses of a coin, this is a fair coin, the probability of getting a sequence of 4 or more of the same result is about 46%, nearly half. Try it out. Try tossing a coin 10 times. But nearly half the time, you'll get a sequence of 4 or more, either 4 heads or 4 tails. And the probability of a run of 3 of the same result is 82%. So it's very near certain that you'll get at least 3 in a row. But most people's idea of a true dice, that truly random, you're not going to get too many running together. But in fact, true probability means that runs or sequences together are quite probable. Here's another one. If I make 1,000,000 spins in an event that has 1 in 1,000,000 chance of winning, what are my chances of winning at least once? So you might think, okay, I'm going to spin the roulette wheel or whatever it is 1,000,000 times, and I have a 1 in 1,000,000 chance of winning. If I spin it 1,000,000 times, I should win. There's a pretty high chance that I'm going to win. You might think it's certain, since 1,000,000 times 1 over 1,000,000 is 1. But not so. The answer is actually about 63%. So here's a case where the probability is smaller than what we might intuitively think. And there's some technical details, the exact answer. You could think of it like this: the probability of getting a head after 2 tosses of a coin isn't 1, but it's 75%. And this is the way you work it out. You go to the opposite case. The probability of not getting a head, the same as the probability of getting 2 tails, which is a half times a half, or quarter, or 25%. So the probability of getting 2 tails is 25%. So the probability of getting at least 1 head is 75%. And it's more technical there. It's generalized out to n times. I got this information from Wizard of Oz. Here's another interesting thing, another random interesting thing about randomness. The shuffle feature on iPods randomly arranged your music collection for you to listen, but people complained because it would regularly play 2 or even 3 songs from the same artist. So Apple had to actually make it less random. People didn't realize that randomness could mean that you're getting sequences of the same thing. But people expect randomness means that things aren't going to occur together. This goes back to the one about getting 3 or 4 heads or tails in a row when you toss the coin 10 times. What people think of as random is actually a little bit more ordered than that, so that you don't get things clumping up together. So there's another case of where probability and randomness is not what we would normally think by normal intuition or expectation.